Hello and welcome to another bonus episode of Memento Melon. To play catch-up, I'm remaking the videos that did poorly due to the audio malfunctions. For this episode, I'll be covering potato wart management, plus a bonus story from Country Guide and the science surrounding it. Let's get started. Potato wart is a disease found in potatoes. The causative agent of this disease is the soil-borne fungi Cyanocharum endobactem. This species belongs to a class of fungi that do not produce mycelium. The fungus primarily exists as single-cell mobile units that move directly into the potato via contaminated soil. These mobile units require live tissue to reproduce and continue the life cycle. The life cycle of this species is as follows. The resting body called a sorus releases 200 to 300 mobile zoospores in response to the presence of a potato or another host that can infect. Upon infection, the fungi will then induce mutations that cause tumor-like growths on the potato. These growths will then serve as a source of food for the fungi. Near the end of the life cycle, when the potato is about to die, these haploid zoospores begin fusing together to form storage organs. As the potato decays and dies, these dormant spores get released into the soil, where they wait for the next host to come along, and they can wait for decades, retaining viability for 40 to 50 years. Eventually these storage or sori, if in contact with another potato, will release another 200 to 300 haploid mobile cells, restarting the life cycle once again. The most common means of controlling this disease is quarantining. Indeed, it's considered a high-rank pest in various national and international government agencies. There are several pathotypes of this disease. There are several different strains of this potato disease, the most common of which are pathotype 1, 2, 6, 8, and 18. As of right now, there's very few cultivars that are resistant to this disease, and only 3 are resistant to all 5 common pathotypes: Carolina, Ulmi, and Petelia. Chemical control is unreliable due to the fact that the disease is in the soil, and fumigating the soil is uneconomical, imperfect, and ecologically really bad. The initial discovery of pathotype 1 led to different breeding practices in the 20th century for disease resistance. One source was Solum aculi, a wild potato species. New pathotypes were discovered over time as well, such as the German town of Giebel and the German town of Silberlet, which housed type 2 and 3 respectively. In eastern Germany, pathotypes 4 and 9 were also discovered. Within western Germany, once again, 2 more strains were found, pathotype 6 and 8. Pathotype 7 and 5 were also discovered within that region as well. The rest of the strains were discovered in Western Europe, the Czech Republic, and Ukraine. It's also discovered that there's a gene called SEN1 that incorporates resistance to tobacco mosaic virus, but it's also linked with a bunch of other genes. So when you inherit that gene, you inherit a bunch of other genes at the same time, such as genes for resistance to other types of viruses, various nematode species, fungi and bacterial diseases, and a dominant gene resistance to pathotype 1. So all they had to do was make sure that these resistant cultivars inherited the SEN1 gene, and everything else will follow. Similar results happened for SEN2, 6, and 18 genes. This led to the breeding of different varieties of potato with this trait. These are, however, single gene traits, which means that they can be overcome relatively easily if they're grown en masse, making them less effective as a means of managing resistance on its own. As a consequence, quarantining is the most common method. You've seen me cover potato wart stories throughout my Memento Melon Today series, and this will explain the quarantine protocol of the Canadian government. But before you do, I would be remiss to say, and miss out on saying, that this disease can cause between... The Canadian Management Plan for potato wart was first designed in the 20th century and remains in play to this day. And it covers 3 different types of fields: index fields, where the potato wart has been detected; adjacent fields, which are next to the index fields, and are not separated by physical barriers; and are not separated by a physical barrier of more than 50 meters. Primary contact fields, which are fields that may have come in contact with equipment or shoes or similar substance that had potato wart contamination, and other contact fields. The strategies are very similar to one another for each field, so only cover Type A fields, because Type A fields have the most expansive strategy. After potato wart is detected in that field, any soil crops are destroyed and disposed of in a government-regulated fashion. Only processing and use within the province is permitted, with risk mitigation measures put into play. Restriction of soil movement and various regulations regarding that are put into place. All machinery must be cleaned and disinfected. Only non-host crops can be planted within that field for the next 5 years, which means no solanaceous crops like potatoes, tomatoes, eggplant, peppers, etc., etc. No material for propagation is allowed. A soil sample of a 4 meters by 4 meters grid soil sampling must be studied for potato wart cells. Post-harvest field inspection of tubers for potato wart is also required. This continues for 5 years. And if after 5 years after detection, when the spore counts are below 5 spores per gram of soil, a bioassay is done. This is where a sample of the soil is collected, put into a pot, and a potato is grown inside that pot with that soil. If the potato gets infected with potato blight, then it's positive. If not, it's negative. If it's positive, you have to wait another 5 years. If it's not infected, the second stage of quarantine happens. For every 5 years, the soil gets tested for potato wart, and a bioassay for potato wart is all conducted. At this stage, you're allowed to use resistant cultivars, and only with full clean and disinfection of the equipment, and the potatoes are only allowed for processing within the province, with risk mitigation pressures in play. After 15 years, and successful tests indicating that there's no potato wart in all bioassays, and less than 5 spores per gram of soil within each sample, stage 3 happens. Production of potato wart susceptible varieties may be permitted. Cleaning, disinfection, and soil movement restrictions may be lifted, except soil must remain on the field. Processing and use remains a requirement. And finally, inspection of potato wart post-harvest must be done in a full crop for 3 consecutive seasons. If negative results appear after these 3 seasons, the farm gets returned to normal. And these are the rules and regulations of Canada regarding potato wart to prevent the spread of this disease. Now let's go. Lastly, we'll talk about a news story by Ralph Pierce of Country Guide, a new source of nitrogen for crops. There's a biological product called Russia N and Navita. These 2 brand names refer to a biological fertilizer that's said to be used for potatoes. Russia N potatoes. Russia N created by Corteva, and Inventa, created by Syngenta. Both of these are strains of the bacterium, Methylbacterium symbioticum, which on paper will colonize the leaves and convert nitrogen gas from the air into ammonium, providing a consistent supply of usable nitrogen. This is what the people at Corteva Agriscience say, who received a certification from an Organic Materials Review Institute. Inventa's active ingredient is another bacteria species called Gluconeobacteria disulficus, and was stated to be successful in fixing nitrogen for sugarcane, and may do well in potatoes. Both groups suggest that this will be useful in sustainable agriculture going forward. In this case, I'm going to play a bit of devil's advocate. Collaborative research by several researchers, Dr. Dave Franzen of North Dakota State University, Dr. James Camberto of Purdue, Dr. Emerson Neffiger of University of Illinois, Dr. Daniel Kaiser of University of Minnesota, and several other researchers from across the United States have tested these products on various crops, specifically corn, wheat, and sugar beets. And the results were, with or without the addition of the nitrogen fixing product, there is no statistical difference between the end yield with or without the biological fertilizer. Basically, they created different trials. In one field, they would have one set of fertilizer and it'd be split in two, with one side having the fertilizer and the bioorganism, and the other side having the fertilizer but no bioorganism. Many of these experiments also had controls where no fertilizer was used, with or without the bioorganism. Of the 61 sites that are tested, this experiment was conducted over a course of 61 site years. Only 2 years showed any statistical differences in yield and yield increase. As such, it's unlikely that these products are actually effective in their stated goal of improving yield in corn and fixing nitrogen into the crop. And that about covers everything. Thank you for watching this video. If you enjoyed this video, please like and subscribe. If you really enjoyed it and think you can donate, you can do so at Buy Me a Coffee, link in the description below. Thank you for watching.